This screencast is on the Keystone practice questions, line of best fit, and scatterplots. So, problem one, Joaquin takes the bus to and from school each day. He records the number of people on the bus when he got on the bus each morning and the number on the people when he got off for 5 days. His data is shown on the coordinate plane below. So we need to find out which equation describes the line of best fit for Joaquin's data. So what I would suggest is drawing a line of best fit first. So remember, your line of best fit does not have to be perfect. It just needs to be kind of evenly spaced among your points. It does not have to touch any of your points. That's okay. So right now we're looking at our line of best fit, and I'm going to suggest looking at our y-intercept. So looking at your y-intercepts and looking at where your line's crossing the y-axis, we automatically can eliminate answer B because that y-intercept's negative and we're not crossing at the negatives. And we can eliminate option D because that's crossing at at 5, and we are not near 5. So we're looking at these two choices left. So what I mentioned in class is that let's pick a point on our line. So if I zoom into my line, I have this point right here where x is 4 and y is 4. So what that means is if I plug 4 back into my equation, I should get 4 as an answer because my x is 4 and my y is 4. My input's 4, my output's 4. So if I check that with problem A, if I take 0.7 times 4 plus 1.1, I want to see what I get. So I'm going to plug that in, and I get 3.9, which is very close to 4. So before I say yes, it's A, I want to check letter C. So I'm going to take 1.0 times 4 plus 1.0, which gives me 5. So 5 is too big. It's going to be A. So all I did is I took my points, I drew my line, and I found out what would make sense with that line by using points on the line and plugging it back in. Okay, so the second problem, Lily works at a company that makes shirts by hand. She recorded the number of shirts, and let's see, it says, which graph shows a line of best fit for Lily's data? So looking at our lines of best fit, we want to figure out, okay, which one is evenly dispersed among the top and the bottom? So A is definitely out because notice how everything's above the line. B is also out because it's kind of the same idea. So we're now looking at C and D. So C has 4 points above, 4 points below. D has 3 above and 5 below. So D is out, so we're left with answer C. Problem 3. Joan delivers small loads of firewood and large loads of firewood to a campground. The scatter plot shows the number of small loads and the number of large that she delivered on the last 10 days. How many of the last 10 days did she deliver more than twice as many large loads as small? So we have to keep in mind that each dot is a day. So we want to figure out, okay, on how many days did she deliver more than twice as many large than small? So let's look at our first day here. I'm going to highlight that. So she did 1 small and 4 large. Well, if we take 1 and we do twice that, so 1 times 2 is 2. So 4 is larger than 2. So that would be a day, I'm going to circle it, that would count. So she did more than twice as many large loads as small that day. Let's look at this day. She did 1 load and 6. Well, 1 times 2 is 2. 6 is greater than 2. So that also is going to be a possibility. So I'm going to circle that day. Let's look at this day. So we have 2 and we have 6. Well, the small load 2 times 2 is 4. 6 is greater than 4. So that's going to be a day. So I'm going to circle that. All right, now we have 3 small and 5 large. Well, 3 times 2 is 6, and 5 is not bigger than 6. So that day is out. So let's look at this day. We have 3 small and 6 large. 3 times 2 is 6, but 6 is not greater than 6. So that day is also out. And then we have 3 small and 8 large. 3 times 2 is 6. 8 is bigger than 6. So that would be a possibility. All right. If we look at the next one, we have 4 small and 4 large. Well, that's not going to work out because the large isn't twice as more or more than twice. 5 small and 2 large, that wouldn't work out either. 6 small and 3 large, that's not happening. And then 7 small and 5 large would not happen either. So we have 4 days where she delivered more than twice as many large as small. So we have answer C. Number 4, store owner buys baseball cards in bulk. The owner recorded the amount Y in dollars she paid for each of the last 10 collections she bought based on X thousand cards in each collection. This is the key right here. X is in thousands. Based on the store owner's line of best fit, which amount should she expect to pay for a collection that has 1,500 cards? So the way I explain this in class is if we were to plug in 1 in for X, that would mean 1,000 cards. If we would plug in a 7, that would mean 7,000 cards. So that X is in thousands. So if we need to plug in our 1,500, we're going to take that number and we're going to divide it by 1,000. And that's going to tell us how many thousands we are plugging in. So we can't plug in 1,500 right into that. It's not going to work. The answer is not going to pop up. So we have to consider writing our X in thousands. So if you take 1.5 times 1,000, you would get the original. So we're going to take 1.5 and we are going to substitute it in for X. So we're going to take 39.94 times 1.5, and then we're going to add in our 3.84. And that gives us our 63 with 75 cents. Okay, so the last one, so we're skipping 7. The last one we're going to look at is number 10, and I forgot to delete that. So for problem 10, what we did in class is we looked at the line of best fit and we're extending our line. So we want to find out what is the number of scratches that could be found on a card that's 30 years old. So looking at my picture, I'm going to extend my line. I know when X is 30, so I'm going to go up to my line and I'm going to see, okay, where, hold on a second. Yeah, sorry. We're going to see where it matches up on our Y axis. So we're going to look over here and it's in between 80 and 90. And you can see that we're going to have 87.